It's not the same by not attending at all. So let me share the screen. At least we cover a gap. It's not the same with not attending. So today
the new girl is not yet here, but is she
okay.
here?
So let's start with the classical mechanics. So this is our assignment number what?
Number 1.
So for what values of A are the vectors A, 2A in the, that I it's referring to in the X direction. So this I, it means in the X direction. J, it has moved in the Y direction, and K in the Z direction. So it is moving A units in the K. So we are having two vectors, which is A and B. Okay. So you must be familiar with the unit vector I, it means in the X direction. Unit vector J, it means in the Y direction. Then unit vector K in the in the Z direction. So it's a 3D. We are moving in 3D, which means you'll be having Z, and then we are having Y in this direction, and then you are having what? X. So each vector, each point, it will be somewhere in the space. It will be somewhere in the space. So if it's somewhere in the space, it's no longer 2D, it's 3D. That's why we are having three vectors, 3 dimensions, X, Y, and Z. So instead of X, they are representing X as I, J as, X as I, and then J as Y, K as Z. That's how they represent that. So if they are perpendicular, which means we want to, for what values of A, which means we are talking of the dot product. What do we mean by dot product? By dot product, we mean the first derivative. And let me go to dot product where it was. This is number 6. The first one, yes, yeah. So let's start with this one where we are talking of the dot product, which means those two vectors, they must give you a sum of, starting here. All right, the two vectors are perpendicular if their dot product is 0. In other way, A dot B, we are dotting those products, they must give you 0. It means those two vectors are perpendicular. For example, vector A is moving in that direction, vector B is moving in that direction. If these two vectors are perpendicular, when we dot the product, it means dot product, we are multiplying, we are going to get 0. So this is what we are going to do before we conclude. So what is our A, and then what is our B, and then we put it like that. So 2A in X direction, you can put it in rectangular form like this one, where if you are dotting the products, for example, 2A, you put in brackets. It can be a square bracket or it can be a round bracket, it's allowed. For example, the unit vector which we are given, you can say A is equals to, you can put it as well in round bracket. It's also allowed. That's what I mean. That it can be square brackets or it can be round brackets. So this is the part which has moved in the X direction, which means 2A in the X direction, and it has moved to -2 units in the Y direction, and it has moved A units in the Z direction. So this is how you can write it so that it's easy for you to multiply. So that it's easy for you when you are multiplying, it's very easy to see that. You do the same for B, A in the X direction, 2A in the Y direction, and also 2 units in the Z direction. So when we dot the product, what do we mean when we are dotting the product? It means the first, this 2A is multiplying it itself by A. From mathematics, it's not the first time using dot product. 2A times A, that is the first part. Meaning the i's, they are multiplying each other.
Answer. Can I just disturb you a little bit? The new girl, she's saying that she's struggling to join the meeting. It's saying that it needs the meeting ID. I don't know what's happening, but she's struggling to join. I don't know if you can assist her.
As you can see here, there's no one here. I have already shared the link to everyone. And if the person wants to join, I would be seeing here someone wanting to join. Then I can admit if the person is joining without the university's login details. If the person is having the university's login details, which means I don't have to approve. As you can see, there's no one on the lobby list.
So what must she do now?
You just have to tell her to, I will share the recording, but next time she must know how to do it. Because this meeting does not need an ID, it only needs you to click. You just click the link. And why is she not on the group?
I think she's there on the group. I added her
When?
that day, the same day that I created the group.
Okay, so technicalities, they do happen. We'll share the recording. There's nothing I can do now because there's no ID that is needed. I just created a link. So let's continue. Yes.
Okay.
Let's continue. So we are applying A, and then now it's B and B. So which means the components you multiply, you don't vice versa. So which means the -2, we are applying with the component for Y. So it will be -2. And remember, you are adding dot product here, it's a plus, which means you are adding all those components of the X and the Y and the Z. That's why we are putting plus there. However, if there is a negative, the mathematics will sort it out. You don't have to worry. So we are going to take that -2, which is this one, this -2, we multiply with this 2A. This is the one which is here. Then we take the last component, which is A, multiplied by 2. So it's A times 2, which is A and times 2. So that's the dot product. So you are taking the first component of the Y for A, you multiply with the first component for X. Sorry, for B. You take the Y component for A, you multiply with the Y component for B. You add to the Y component, the Z component for A, you multiply it with the Z component for B. So in that order. So now it's a matter of now simplifying and seeing what we are going to get. By simplifying those two equations, we see what we are going to get. Let's simplify. We are going to get 2 times A. What are you going to get? 2 times A is going to be what? 2A squared, isn't it? 2 times A, this part. Are you still there?
Yeah, so I think I'm a bit confused. You said that to prove that something is perpendicular, we need to use the dot product, right? And
Yes.
then you gave
But
us
here we want the values of A that are going to make this perpendicular. We are not, for this one, we want these values of A, which are going to give us orthogonality, which means perpendicular. So first, we are going to solve this, and then we equate it to what?
0.
Yes, then we can solve for A. That is going to satisfy that equation. Any question?
so you only took the values of A only.
And B as well. Remember, we said A, 2A, first component multiplied by the A.
I think I'm a bit lost. Yeah.
What does dot product means? You are multiplying, isn't it? So 2A, which is here for A, you multiplied by that A for B. Can you see? This 2A, which I circled now, which is this one. Then you multiplied by the second component, which is this one for B, which is the
Which
X
is
component,
A.
which is A, which is this one. So you only multiply in that order. The x for A multiplied by the x for B. The y for A, here, in this case, it's -2. Then you also multiply it by the y component, which is
-2 multiplied by 2a, and then
which is
a multiplied by 2.
yeah.
Oh,
So which
okay.
means, yes, which means at the end of the day, you are adding the sum of all those components which you have multiplied. At the end of the day, you add them. That's why there is a plus there. Is that clear?
Yeah.
That's where the pluses are coming from. We are adding all the component in the x direction, the component in the y direction, the component in the z direction. The z direction is just like k with the head, the component in the j direction, which means this is the y. The component in the x direction, this is just I, like that, in that fashion. So we have used this method. Why? Because you want to solve for A, which is going to make these two vectors to be perpendicular. So should we continue now?
Yeah.
So if you are to continue, then it's fine. So now after we have those components, we multiply here. 2 times A, we are going to get what?
2a
2
squared.
squared. And then positive times negative, that is the negative, which is there. Then 2 times A, it's 4A, and then 2 times that is 2A. Then you group the like terms together, which is those minus 4A and 2A, it gives you what? 2A.
-2.
The first one is 2A squared. So that in the final step, now we are equating to 0. Since you said this dot product is equals to 0, which means that 2A squared minus 2A is equals to 0. Using your mathematics, you factorize 2, or you can divide both sides by 2, which means you're just factoring out 2. Okay, so which means if you divide each term by 2, here you divide by 2, each term by 2, this one divide by 2, this one by 2, then which means you are going to get A squared minus A is equals to 0. Then from there you factor out factorization. Common factor is A, which means A bracket A minus 1. So in other words, for us to those vectors to be perpendicular, A has to be 0, equals to 0 is a factor, or
Equals to 1.
A should be equals to 1. Where is the 1 from? It's coming from the fact that A minus 1 is equals to what?
0.
0. Therefore, A is equals to 1. So our two answers are A is equals to 0 or A is equals to 1. Because the question itself asked us, what are the values, or what values of A are vectors, this A and B perpendicular. So can you see 12 marks giveaway? 12 marks just give away marks. So just to say that A is going to be 0 or A is going to be 1.
Yeah.
There was nothing difficult. There was okay. You do the dot product, you solve the quadratic, then you show this. We say A is equals to 0 or A is equals to 1. Those are the two values for A. Those are the 12 marks. Now we go to number 2, which is saying show that delta, it means the partial derivative twice. So it's a matter of just knowing the symbol for delta Rn. What does it mean? So we want to show that equals to this for the first part. So how are we going to show? How are we going to show Rn, which means it's the partial derivative with respect to f, which means twice. So let's start.
So that delta signs means is a second derivation.
Yes, the del is del operand, for example, here. is del, which is here. Can you see? It means it's the second partial derivative. That's why it's del squared. Where is the partial derivative? That I can show you. It means it's the second. You are right. It's the second partial derivative. Can you see this one?
Mm.
Mm-hmm. So whenever you see del to the power Rn, it means second partial derivative of R to the power n. That's what we do. All right. Should we continue now?
Yeah.
Okay. So for the first one, we need to know our question for the second one. Remember, we are calculating at delta R to the power n. At delta R to the power n, which is the del operator. Okay. So which means if it's operating on Rn, which means it will be the second partial derivative of R to the power n. So first we must know what is that R first before we go any further. We must know what is the value of R. So R, which we are being given, so want this. So you see the difference between the del operator and the delta. This del operator for the second partial derivative. It's different from the one for change, which looks, see, it's a triangle that is facing downwards, the del operator. Okay. So don't forget, don't confuse it with this one for change, which is facing upwards. The point is having a vertex pointing upwards. So this del operator, the vertex here is pointing downwards. Is that clear?
You said what's the difference between the one that is facing upward and downward?
This one is for the second partial derivative.
Yeah.
And then this one, it's change, the difference between the highest minus the lowest, the change.
Is it the one that we use when we are calculating the gradient?
Yes.
Okay.
All
Yeah, we
right.
can
So
continue.
what is R in terms of the Cartesian coordinates? Our R in terms of Cartesian coordinates is the same thing which I was drawing before, which means R is having 3 dimensions, which it is composed of the Z, composed of the Y, composed of the X. So R is anywhere in the space. That is your R. So R is having coordinates in the X direction, in the Y, and in the Z. That's why R, that R which you are looking for, the magnitude of R, it will be the square root of X squared plus Y squared plus Z squared. It's now in 3 what? 3 dimensions. Is that correct? Yes. So when you are differentiating that square root, remember when you are differentiating a square root in calculus, you remove that square root and then you say to the power what?
True.
The magnitude R, it will be to the power half, isn't it? Hello? Square root. The square root. Square root as an exponent, isn't it? It's to the power half. Anything to the power half. Yes. Maybe you did not hear it very well. So that is the square root. All right. So this R which we are having here, we can write that R is all those dimensions to the power what?
To the power half.
The power half. That is the half which is there. So if I want the partial of R with respect to X, which means I want the partial derivative. Partial of R with respect to X which means everything is constant except for what? For x. That is the partial derivative. We are differentiating with respect to x, and everything becomes constant. So if you differentiate this function with respect to x, what are you going to get? If you differentiate that with respect to x, what are you going to get? The half, which is the exponent, is this one. It comes in front. Is that not so? Chain rule. Are we the half, which is the exponent. Which half am I referring to? I am referring to the half, which is the exponent, this one. I'm going to put in green. This half, which is the exponent, in green, is the one that has come here to the base, the chain rule, where it says x to the power n. How do you differentiate x to the power n? You say n multiplied by x to this very same power, but subtract one. 1. Yes, that's what is it. So we are doing the same thing. So that's where the half is coming from. X to the power half, then what is inside the bracket is x. Same thing that is inside the bracket, you copy as it is, to the power n minus 1, which means to power half minus 1. What is half minus 1? It's negative what? Negative half. Then you multiply everything by the derivative of this. That's why they call it chain rule, the derivative of x only, because y and z are what? They are constants. Because we are now differentiating with only respect to x first. So that's why our answer there is going to be half x squared. Then we multiply by the derivative of what is inside, which is equals to x over r. Is that correct?
So,
All right.
say, question, previously you said that R is everywhere, ne? The R. So now that you are deriving with respect to X, are you
Yes.
still gonna derive with respect to Y and Z again?
Yes, yes. You derive with respect to y and z, and at the end of the day, what do? You add all
Okay.
components. That's why there is a what? There is a plus. Can you see?
Okay.
That's what. And where is this x over r coming from? Because we are saying, if you are simplifying this first expression, it's half. It's half. And then we are multiplying by 2x. Can you see this 2x here? Yeah, so it's half multiplied by the 2x. That's where it is. And this x squared plus y squared plus x squared is to the power negative half. So which means we are also multiplying by negative half. It means 1 over everything that is there, which is x squared plus y squared plus z squared. So everything that is there down there, the square root to the power half is the square root of everything that is under there. That square root, we can replace that square root of everything that is under with just an r, because we know square root of everything that is under here is the same as what?
R.
So if these 2 and these 2 cancel, now we'll be left with x times 1. It's x. R is on the denominator, which is just r.
Okay.
Yeah, that answer. That is x over r. So if you do the same with respect to y, it will show you, it will be left with 2y, then it will be y over r. Always the denominator is not going to change. Then if you differentiate with respect to z, it's going to give you half multiplied by 2z times 1 over r. Then you are left with what? Z over r. Okay. Are we together? Yes. So as a vector, we are having a x in the y, common factor there. Where did this thing come from? So we want to verify. So our gradient, this partial difference grad R, this is what we are referring to, is equals to, R is common throughout. So it's 1 over R. You factor it out. It's common throughout. So I've seen that I'm applying by X in the I direction, and don't forget the head on top, plus Y in the J direction with the head on top, plus Z in the K direction on top. So that's where this vector is coming from, the one with an arrow, which means the R. This is the one, which is where it's coming from. This one. It's coming from the fact that it's X in the X direction plus Y in the Y direction plus Z in the Z direction, which is K. So it gives you the vector R over R. We have already shown that because that's what we were supposed to show for this one. We're supposed to show grad R to the power N is equals to N multiplied by N to the power minus 2. So here we were using grad what? Grad R. That is the one which we used for grad R. But it was not grad R to the power what? N. Can you see the difference? Plus, this is gradient of R. We found that the gradient of R is equals to the vector R over R. The question itself is asking for the gradient of R, the power N. Can you see now?
So sir, the gradient, the R, the one that has a sign on top.
Yes.
The X, Y, Z, those, is it a vector? Is equals to that. It shows
Yes,
that it's a vector.
Yes, it's a vector. That's why the R is having an arrow, it's also a vector. Then this R, which is down here, it's the magnitude of that vector.
Okay.
Yes. And you can put it like this. Some books, they do it like this, magnitude. Or some texts, they put this R in bold. If it's a vector, the one which is on top will be in bold, and the one on the bottom is not. Some textbooks, they put the R with the vector if they don't want to put it in bold. Then some R over R. Then this one, some books, they put it in bold. You find out it's to be black. And then they just say over the R, which is faint. Then you must know the top one is a vector. Okay. So our question we have not answered. The question which we're supposed to answer is, what is the gradient of R to the power N equals to? By following this step, what can you conclude? The gradient of R power N. How are you going to solve it? You want to solve for R to the power N. Let's go. Isn't it for the first one we showed you for R to the power, which is just the gradient for R. You do the same. If you are given R, you know what is the value of R. And I indicated that whenever you see the magnitude, the absolute, it means magnitude, okay? That absolute means magnitude. So R to the power N, this is R to the power N. We are just now introducing, since we said square root is half, so it will be N times half, which is as an exponent outside. So this, it will be to the power N times half. That's why it's N over what?
Over 2.
N over 2. That's where it's coming from. Then you do the same thing that we're doing. Now you don't want gradient of R. You want gradient of R to the power N. So which means you do the same partial derivatives of what? Of R to the power what? N. But before you make it r to the power n, you need to let, since we are going to be having many variables, which is n and x. So letting u, so that it's easy to simplify, to differentiate. Remember, letting u is equals to x squared plus y squared plus z squared. That is your u. Then r to the power n is the same as u to the power n over 2. Why did we introduce u? We are just making it easy for us to simplify.
Mm.
Yes, because the variables, there are now many. We have introduced n. If there was no n, we just treat it like the same way we were doing straight away. But whenever we introduce that n, we need to let. Okay. But after you are done, at the end, where there is u, you put back the units for u. That's what we are going to do. Right.
So
So let
then the R for magnitude. Is it its formula that is always equals to square root of x plus y and plus z squared?
yes, always.
Always.
It's always, yes, it's always. R is equals to the magnitude, which is the square root of x
X
squared,
squared plus y squared plus z squared.
just like the distance formula in metric. Distance formula is equals to the square root of what? X squared plus y squared.
Y
F,
squared.
that is the
But we
distance
don't have the z. Yeah.
z, because it's 2D at metric level.
Mm.
Now we're in 3D. So you use the differentiation rules to solve for this one. Let u equals to x squared plus y squared plus z squared. So r to the power n is the same as r, which means because of the square root. That's why it's n over 2, we have already indicated. So you are just replacing where there is x squared plus y squared, you're just putting. Then now it comes to the differentiation part. So partial with respect to x. We are now having a partial derivative with respect to x. So it will be n over 2u to the power n minus 1, and then 2x. Even if you didn't want to include, to letting u, it's up to you. If you feel that letting u is going to confuse you, you can take it directly. Then you just continue the way we have been doing. But you must also note that where there is n over 2, it's going to, where we were saying half minus 1, now it will be n over 2 minus 1. That is the only difference. It's not a must that you can let u equals to this. You can skip that step, then you differentiate without letting u, depending on how you understand, isn't it?
Mm.
Yes, instead of you going this route of you letting you just put your answers, because you already know it's the exponent, you bring it down, n over 2, bracket, x plus y squared plus z squared to the power n over 2 minus 1. Then you do the same for the rest of the, remember here we'll be multiplying each term by 2x, 2x. That's why the 2 and the 2, they cancel. What are you left with? If the 2 and the 2 cancel, you are left with the n, which is this n. As the multiplicand, this n. That is what is left out. And you'll be left with the x. You'll be left with the x. Then you say x squared n, and you'll be left with the x squared to the power x squared plus y squared plus z squared to the power n minus 1. Multiplied by the derivative of what is inside, which is 2. This derivative. If you are dealing with x, you are going to get 2x. The derivative of what is inside. So the 2x, it cancels with the 2. This is the 2x which we are referring to. It's coming from the derivative of what is inside. So the 2, then the 2, they cancel. Any question there?
Hmm? Yeah. The 2x is the one that we derived with respect to x, right? Because y and z are constant. So
Mm.
now we still divide the x squared, which is inside the square root or the bracket, with the 2x.
Yes. Where are you lost there? Which equation?
There where you just circled, the one we're just explaining now, there were 2x, you divide it with the x squared. Yeah, there.
Okay. Let's use the alternative method. From here, we are just saying if we were differentiating with respect to x,
Mm.
we are differentiating with respect to x. Which means our delta r to the power n. So the first one, if we say partial r partial x, this statement which we are having, and not forgetting n here as well. Partial r partial n x. So which means I said you copy the whole statement. So to the power n, which means it will be n over 2, which is your constant, multiplied by x squared plus y squared plus z what?
Squared.
Squared. Yes. It's to the power what?
Um, n over 2 minus 1.
So it will be now n over 2. We subtract what?
1.
1. Yes. We subtract 1. Then we are not done. We differentiate by multiplying with what is inside, the derivative of what? Of 2 of x squared. What is the derivative of x squared?
It's 2x.
That's what we mean. Let's put a different color. So it will be multiplied by 2x. So that this 2 and this 2, they what?
Cancel.
They cancel. And we are left with what?
N.
nx, isn't it?
Mm.
Yes, we are left with nx. This is the nx that
Mm.
which we are referring to. So nx, and we are left with this argument, which is this one,
Mm.
which is plus y squared plus z squared to the power n over 2 minus 1. That is only for differentiating what? For differentiating a partial derivative of r to the power n with respect to x. What about if you differentiate the partial derivative of r to the power n with respect to y? What do you think? How is it going to change? If let's say you are differentiating with respect to y, you are simply going to come here and then say it's going to be n what? N what?
NY. Mm.
Isn't it? Everything stays the same, isn't it?
Mm-hmm.
NZ, etc., isn't it?
Yeah.
So NY, NX, NZ multiplied by that bracket, it's this one. This is the N and this is the X. Can you see the X? That is the N and this is the Y, which we are saying NY. That is the N,
Oh.
that is the Z, which we are calling N what? NZ.
Mm. Mm.
To get one what in one bracket.
Mm.
And then this argument that is hanging on itself, which is left out for all values, this is the one which is here, which is N. So this is the gradient of r to the power n. Then we need to simplify it. We are not done. We need to simplify it because we know that x squared plus y squared plus z squared to the power half is equals to r. So we know that is equals to r from the definition there. So if it's equals to r to the power half, how did we manipulate this statement? Already this one we know it's what? What is this in terms of vectors?
Is r with this
With an arrow on top, isn't it?
mm.
An arrow on top. This is the one which we are going to multiply. So it's this one. So we just want to manipulate this statement. N is already there outside. Can you see N? N is already outside. So it's a matter of just manipulating x squared plus y squared plus z squared to the power n over 2 minus 1.
So because the square root there is gonna be negative half, so it's gonna be n to the multiply by the vector over the r, which is x y z at the bottom.
So how did we get the minus 2? How did we get minus 2? Where it says n to the power minus 2, where is it coming from?
Because it's underneath when you
So
no, I don't.
it's like this. It's like this. Let's say n over 2 minus 1. 1 as a whole number is 1 over what?
1
over 1, isn't it?
Mm.
Then if the common denominator is 2, 2 goes into half how many times? 2 goes into 2 once, which is n. N minus 2 over what? Over 2. N minus 2 over what? Over 2. Why is it over 2? Because r is already having a multiplier of half. So which means it's like this. If it's the half, it will be half of n minus 2. Something like that. Remember, it's to the power half n minus 2. So another way of writing this, n minus 2 over 2, you can write it like this. Half multiplied by n minus 2, isn't it? Half multiplied by n minus 2. This is another way of writing this. Where is the half coming? How did this half disappear now? That's what I'm saying. How did this half disappear? How did this half disappear? If you are going to tell me. Because I was here on the exponent. Then all of a sudden, I got this one, n minus 2 over half. And after that, I got half multiplied by n minus 2. But here, I don't have half multiplied by n minus 2. This half is contained in the r. This half, which is disappearing here, it's contained here in the r. It's already there in the r. So since it's to the power half, what is only left on the exponent to which you are going to multiply? Because the half, we already have it, this one. Already you are having your r, but you don't have n minus 2. So which means I must say half multiplied by n minus 2. That's why here on the r, I added n minus 2. So that I can come and prove the statement. Because it's a matter of you showing that from here, how did you arrive to this point? Are you understanding why we cleared this half out?
No.
Yes. What is the problem? Where are you lost?
So from the from the let me say equation, the n over 2 minus 1. I understand. So Now you wrote the n minus 2 over 2, which the 2
All right.
is the
Let me show you. Let me show you. Let me show you. We make it clear again so that you understand. Let me show you. All right. From there, we want to show you how we arrived from here. We want to show you how did you arrive at this point, isn't it?
mm,
Yes, that's what we want to show you. How did we arrive at that point? So what I'm saying n, we are already having it. N, is it a problem? For n, how on our equation, n is not a problem because the n is already there. This n, this is the n. You see it?
the one that you just circled. Yes,
Yeah,
that is
that's the
gonna.
n. And then let's go to the r. This is the r. Any problem with the r?
No,
The
no
r,
problem with the n and no problem with the vector. The problem is with the
r
that one, the
power.
magnitude.
Yes, yes, yes. So that's what I want to explain. So it's going to be x squared plus y squared plus z squared. Everything to the power,
Half.
we say n over 2 minus 1, isn't it?
Mm,
Then I told you, how do you simplify n over 2 to the power half? It's this. It comes to here. Are we together here?
mm,
It can be written as n over n minus 2 over 2, which can also be written as half. Can you see? Multiplied by n minus 1 minus 2. Are we
mm,
together?
mm-hmm,
Are we together?
mm.
Yes.
So the negative 2 on top, you wrote
Mm.
it so that when you divide it by 2, it's gonna give you negative 1, which will also take you back.
Yes, it will take you back. It's just another way of rewriting this expression. So which
Okay.
means this expression can also be written as half multiplied by
N minus.
n minus 2,
Mm,
because half is a common factor.
mm,
Yes. So which means from there, I can notice that using a different color, I can notice that this part, this one, this part,
mm,
this is what can also be written as r, because r is the square root, which means
mm,
to the power half. So
mm-hmm.
instead of what I've put in purple, this one, I can replace it with one variable. What can I replace it with?
R.
R. So instead of writing everything, I just put R. But automatically, there is something there which is multiplying R in the exponent, which is n minus what?
N minus 2.
And on the right-hand side, I have this guy here, which is the same as R. And then the n is in front. I'm looking for the gradient of R to the power n. That is where it's coming from. Any question?
So what happened to the half that was multiplying? Remember, we have 1 over 2 n minus 2. What happened to that half? Because R comes with its own half, which is the square root.
Mm.
So what happened to that half that was multiplying the n minus 2?
What happened to the half that was multiplying what?
The n minus 2. Remember, you told us that it can also be written as half
It
multiply.
comes, the half which is multiplying is this half, which is here. Hmm? That half which you are referring to, this one. That is the one. So how do I replace the whole term, this whole term which is in purple, highlighted in purple, this whole term? How do I replace this whole term, even with the half on top? You replace it with just an r, because r is the same as x squared plus y squared plus z squared to the power half. So instead of writing everything there like that, I can replace it by just putting r.
Oh, that half is the one that is there because already we derivated from the beginning. Oh, I
Mm,
thought maybe now we are having two things. No, I
no,
get that. It's the
the
same
half,
half that we
the
were
half is just
multiplying.
for the r is the square root, the magnitude. It always has a square
Mm.
root, which is half. We have not differentiated anything. It's just from the basic, the distance r, the magnitude of r is just x squared plus y squared plus z squared, square root. Another way of writing square root is half to the power half.
Mm. So now the n minus 2 it's the square root of r, right?
This n minus 2, it's what is hanging there on top. It must
Mm.
be the exponent.
Oh yeah, no, I get it now. Hey.
Exponent, yes. So that was the trick.
Oh,
Okay. So we'll continue tomorrow.
yeah.
Other ones for partial, yes, we conclude. Just digest on this one. You see where you are not getting it right, then I can explain again tomorrow before we start.
Mm. Okay, please just send us the notes and the video in the group. Okay. Thank you. Bye.